Hi, this is a quick video to show off a new feature of MegaSplat. In my last major update, I added support for tessellation, which is a great feature. It looks really amazing. The problem if you use it in an actual game is that if you have physics interactions with the terrain, which most games do, then you'll notice that they don't pay attention to the tessellation at all. That's because the physics mesh is untessellated. The only real answer that would 100% work across the board in all cases would be to tessellate your physics mesh to some incredibly high resolution mesh and displace it. But that's not really practical because if you were to do something like that, you would basically run out of memory because you would have million, polygon meshes sitting around just for collision. So instead, what I have is another technique, and I'm going to show that off right now. So I have these spheres up here. If I hit play, what you'll see is that they fall and they start rolling down the terrain, and you'll notice that they hit all the little bumps in the tessellation and act just like this physics mesh is heavily tessellated and displaced like the terrain is. But it actually isn't. I'm going to turn on a debugging feature, and I'll show you what's really happening. So if I select one of the spheres, we'll select this first one, and I go to the tessellate physics floor component on it, which is what's doing the magic. I turn on show debug. What you'll see is that as the sphere moves, there's a little plane underneath of it. This is actually what the sphere is colliding with. What's happening is each frame, it's raycasting down, determining where the physics intersects, where the raycast intersects to the terrain. And then in software, it's doing a little displacement and putting a plane there that is sloped and orientated to follow the tessellated terrain. And so that little trick allows us to have an untessellated terrain and have all these objects act as if the terrain is highly tessellated. So if you go with that debug option on, if you go over to where that originally fell, you can see all these little balls. These are showing, it's basically some debug output for me so I can see what it thinks the terrain tessellation is. And you can see how this follows over this tessellated hump perfectly. So that's the trick, is that rather than tessellating this terrain into millions of polygons, which wouldn't be efficient, we just do a little local computation of the displacement and put a plane under there, and the system basically intersects with that plane rather than intersecting with the terrain, and everything works as it should. Now, this isn't 100% general. It's just going to work for everything use case. More, it's an example of how you can use the MegaSplat API to integrate physics into your particular use cases. If you're doing like an enemy's character controller, and you've got an enemy that needs to run around, and you want them to follow the terrain, it's probably fine. But if you have a main character, you probably want to do something like have one of these controllers for each foot, and then IK the foot to the result. So the API makes this very easy. Basically, to set this up, there's a few things you need to do. One is that on your terrain, you add the MegaSplat's collision info script, and you give it a texture list. So this script allows you to query a collision and get which texture you've hit. It also allows you to get the physics offset for the tessellation. And in this case, because I'm using a two-layer shader, you need two-layer turned on. So you put that on everything that you want to collide with. In the case of the sphere, if you just need a simple physics floor like I've done here, you can add this tessellation physics floor example. This script is only like 30 lines long, so it's pretty easy to use the API. You should be able to tell what you need to do from there if you need something more advanced. I'm going to turn off the show debug. And then the final thing you need to do is actually generate the data that the CPU uses. So if we go into our terrain textures here, into our texture array, and we select the diffuse array, there is an option now for physics data size. And so right now I have this set for 64 pixels. Basically what this will do when you set it, and then you hit update and recompile the array, it will create a physics folder, and it will make small versions of your height map textures for you that are all set up, and it'll add them to an array that we can read to get this data. So I have these at 64 right now. You could probably go lower. You can tell that it represents the general shape pretty well for any large tessellation area. Really tiny tessellations it won't obviously represent as well, but for physics you probably don't need that. So once you output this array and you add those components, then everything will work as it should, following the tessellated terrain. And just really quickly, we can look at that script. Bring up my editor here. Is the collision info here. This component is what you're going to add to the objects. It will handle getting that data. It has two public functions. One which is to get the texture name, and the other one, so this is to get the offset position. So get physics offset position, you give it a raycast hit, and it'll return you a vector 3. And then for the normal of the raycast hit, you can use the original normal. I may add support to get the perturbed normal, but at least in my sort of test, that hasn't really been worth doing. So if somebody wants that, let me know. And then if we actually look at the example script, which is this tessellation physics floor script, this is well commented, so it should tell you what everything is. We have a physics object that we create initially. That's that box that you see below it. We set it to ignore the raycast because we don't want to raycast with that box. We want to raycast with the terrain. And then we set up some scaling. And then in the update function, we're just casting a ray down in this case. For fast-moving objects, you may want to cast in the direction the object is moving. But you basically just do a ray cast. You get the thing that you hit, and if it has this MegaSplat collision info, then you can get that hit offset. And in this case, we just set our position and rotation to be that so that our sphere will collide with this dummy physics object. The other code in here is just that testing code to put all the spheres on the terrain, which only runs in editor and is only if the show debug feature is on. So that's it. Hopefully this will let you turn on tessellation and get large tessellation factors and still have everything in your game work. Let me know if you have any other ideas of how this can be made better, and I'll talk to you again soon. Thank you.